No matter what research you do, we all want that aim of trying to get our research data a lot quicker and a lot faster, which is why today's video is all about 5 ways we can actually generate our data a lot quicker. So without further ado, let's get straight into it. So number 1 is all about working in batches, and actually my favorite tip for today's video, because no matter what research you do, whether it's qualitative, quantitative, whether you're in the lab, growing cells, working with proteins, you name it, there is always a potential that you can do some of that work together in batches. So what I mean by that is, if you have similar work to do, so for example, let's say you're making up buffers, let's say you're diluting out something, and you need to do a few of these, do it in batches. So do it in blocks of similar work together, because it actually makes you more efficient and more effective. If you go from task to task, you have to set up this, you have to set up that, you have to go find this, you have to go grab something from a different freezer, or you have to set up this interview and do it that way. Doing things in batches makes it a lot quicker, a lot more effective, and a lot more, I can say a lot less energy is required, because you're doing a similar task, so you can go from that to that in that block. Once you finish all of those dilutions, or you finish all of that cell culture, you can go into the next bit, or you can go into the next bit. And it's actually really important for when you're doing long forms of research for months on end. It's good to do things in batches, then do the next thing in batch, then the next thing in batch, so you can generate a good amount of data. And there are times where this is not possible, and that's of course understandable, but where you can try to gather data in batches, try to analyze data in batches, try to set up and prepare experiments in batches or interviews in batches, that way you're going to be a lot more effective in the long run. Number 2 is all about the Super 30. I don't know why I gave it this name, but it's essentially when you are finishing the day, at least allocate 30 minutes towards the end of the day to prepare for the next day. So let's say you've got some experiments going on, you've got some analysis going on. Leave yourself 30 minutes before you declare yourself you finished for work or research that day, whether it's preparing something, and diluting something out, or making something up, or getting some plates ready, or getting media ready, or preparing to transcribe an interview, whatever it may be. Make sure you have 30 minutes to prepare for the next day. The reason why is when you come into the morning, you might be late from work, or you might be late to work, you might be something else has happened that you need to attend to. That 30 minutes of preparation the day before will allow you to hit the ground running in the morning of the next day. And let's say you get there early, you feel a lot better, because a lot of the antagonizing, boring work was potentially done in that 30 minutes or however long you want to use, and then it allows you to have a slightly easier morning, and then it gives you that motivation to get these targets done or get this data out, and then you're in a nice momentum, and then that day you prepare for the next day. So if you keep this going, you've got a very nice cycle of a very effective morning process, which allows you to be more productive as you go throughout the day, and then you can prepare for the next day. So Super 30 is actually something really important. It doesn't have to be 30 minutes, it could be 10 minutes, it could be 1 hour, whatever you think is more suitable for your research, but just try to aliquot. I don't know why I'm saying aliquot, because I think I've been doing a lot of aliquoting recently in one of my jobs, so it's probably why. But allocating or allotting time in towards the end of the day before you finish for the next day. Number 3 is about having a whiteboard present, especially if you're working in a lab, because a lot of times we have this idea or quick calculation or something that we need to remind somebody else for, or something that we found that we need more of, and we find ourselves writing on a glove or writing it on the bench or in a notepad. But then we can get rid of that glove without knowing, and then we've lost that idea. Or when you write on a piece of paper, that paper can get lost, and it's very, very common for that to happen. The reason why I say a whiteboard is you can rub it off when you're finished, and you're not wasting any paper. You're not adding to excess waste when it's not needed. The great thing is that you can draw diagrams, you can draw things quite easily. Somebody else can also use that whiteboard, so you can have a kind of communal whiteboard. And the great thing is that can just stay in the lab, and whether it's a whiteboard for lab orders, a whiteboard for quick meetings that need to happen, or a whiteboard. You can have several whiteboards, and you can get cheap ones from wherever you are. You can just have it because you're not going to write too much. And the thing is that why I prefer this over a notebook for this particular type of to-do list is that then other people can add to it, because if you're working in a research group, and people can cross it off for you, and then you can wipe it off ready for the next week. I think it's a really good way to minimize a lot of issues and a lot of unfortunate delays in trying to get your data out quicker when there's an organized protocol within the lab. And a whiteboard for me, and I've seen it in a few actual research labs across the UK, that you can actually have a more effective work day and workflow when you have a whiteboard or multiple whiteboards for different purposes that can be easily written on, diagrams, tick box, wiped off and ready for the next week. So it's reusable. I think that's one of the key importance of a whiteboard. Now, number 4 is all about labeling and coding. Now, it sounds very obvious, but the coding part is actually really important because you might have a lot of samples and it's very arduous to write a whole long list of what it actually is. So you can assign a code, a very short code that describes or is related to what that sample might be, or what that reagent might be, or what that, aliquots in your -80 freezer, whatever it might be. It will allow you to label things a lot quicker by using a code rather than the full thing of what that patient sample might be. And whatever work you're doing, you might have a lot of items of a similar thing. So if you were to write a code, so you know that that code is related to this, that code means it's this, that code means it's that. And the great thing about this is that you can have that code, whether you can have it confidentially kept within your research group and your supervisor, or if it's just something quite obvious, you can just have that code on your bench. So let's say you're not there and somebody's like, oh, what does this code mean? You've got the code on your bench. Okay, x72 means this, x73 means this, xy means this. You see what I mean? And that reason why this is actually really important is if you're doing a lot of work where you have to label a lot of things, it seems very cumbersome to keep labeling out the thing time and time and time again. So you could have ready-made, reusable items where you can just label it once. And if you can't do that and you have to label it many times, have a code because it's a lot shorter than the longer form, and then it will save you a good half an hour, sometimes an hour, if you're labeling large amounts of samples. You can have a number, you can have an alphabet, you can have a symbol if you want to. The whole notion is that everybody knows about labeling, so it's nice and organized, but sometimes we forget to label and code things to make it quicker for us to label items. So it's not just organized, it's actually more effective and more streamlined because we're not spending so many hours potentially labeling out the full name. And it seems very cumbersome if you know what it is. Simple code, simple list, everybody knows about it, those who need to, and then you're actually on to doing the experiment rather than sitting here labeling time and time. That's the pepper, I meant the pen, when you're labeling things for too long. So have a think about coding your samples. Now, last but not least is I think, not my favorite, but I think a topic that everybody needs to look at. And that is the notion of introducing automated templates and automated forms of data processing and analysis. Now, that's essentially a gobbledygook of trying to make things a lot quicker once you've gathered that data, from raw data to potentially finished data, where it might be a graph or figure. And it's to have Excel spreadsheets or Prism, whatever software you use, whether it's coding, is to have automated presets or templates that will analyze the same data for you quicker than if you were to do it manually. So you might have certain formulas in Excel spreadsheet, you might have certain commands in Prism. It's trying to make things that take 7, 8 steps, 7, 8, 9 steps into one by having a code or a command or a formula. So wherever you can do this, and even if it is you're doing qualitative work and you're trying to analyze certain patterns, there may be certain softwares or maybe certain tricks within that scope that you can use to try and streamline the notion of spending hours of doing this, where you can potentially do it in half an hour. And very apparent to, unfortunately, lab work, because you use a lot of digital softwares to try and look at percentages or downregulation or something. And we can have commands especially in Excel spreadsheet, which a lot of people use, and Prism, which is something a lot of people use as well, especially in the quantitative in vitro area, which is where I'm from. So the notion is that even if you have to process data, you have to transfer data, is there an automated way you can streamline that? If you're now analyzing the data, is there an automated way that you can analyze at least half of it? Is there an automated way that you can assign names to it? Is there an automated way that you can then transfer it into a graph? You see where I'm going with this. So it's the notion of trying to streamline a lot of steps that you're doing constantly, time and time again, into one step. If you know you're going to be doing that type of assay or that type of work time and time again, make sure you have an automated procedure is really, really important. So guys, those are 5 little tips to try and generate that research data a lot quicker. I do hope you found it useful. If you did, do consider subscribing, as you can see here. Click that notification bell so you are notified when I upload. And if you can click a like if you did enjoy it, so it helps the video to reach more people, to help more people generate that data a lot quicker. If you are new to the channel and you're unsure, I do have an Instagram page, Aamir.phd here, where you can follow me there for more short form content that is related to the YouTube videos that I post. And if you want to stay tuned even more, you can subscribe to the newsletter down below, where I share video related topics and more research advice for you in your email thread. So then you won't miss any research advice that I try to share. But hope you enjoy the rest of your weekend. I shall hopefully see you next week. Take care.